Let's say we have a function. Not this function, but this function. It expands to become this function block that has a series of instructions, and our interest is the return statements. Now let's say we have another function which requests value from our parent function. Well, not to make you confused, this is our parent function and that is our Callie function, or a function which is responsible for getting values from a parent function. So we have two types of statements. One is return true and another is return false. Now let's say we have two separate Callie functions asking for a value from our parent function. Now the program will be confused on what to do and where to return the value. So to solve this issue, let's understand how a function call works. Well, a function call translates to this piece of code in assembly language. If we dive inside the CPU, we can see that there are registers. But the register we are interested in are known as program counters or as instruction pointers. They contain the address of the next instruction that is to be executed. Now let's look at the structure of RAM. It is a stack design containing memory addresses. Whenever a function is called, the CPU stores the return address onto the RAM and sends the flow of control inside the function. Now the program creates a region of space above the saved return address, and that is called a function's stack frame. Inside this stack frame, there are two more variables, the SP and BP, named as stack pointer and the base pointer. The stack pointer denotes the starting location for the storage inside the stack frame, and the base pointer denotes the termination of the storage. As we can see that the integer I we had declared in the program has got put into the stack frame. Whenever the execution gets over, the address location collapses and so the stack frame. In the assembly language, the return statement is executed as ret, and a new return address replaces the existing address. The value which is returned from the function goes either into the AX, EAX or RAX register inside the CPU. Now let's say a function returning 0. Well, it can be translated as the assembly code like this. The return address, that is the current new PC, has the address of the next instruction that is to be executed. Well, careful though, hackers love this address to break in a system.